Okay, good afternoon, grade 11. How are you today? Today we will start with the next lesson, computing limits. In this lesson today, we learned how can we find the limit by equations. How can we find the limits algebraically without using the graph? How the techniques will be. The first step, we will try to the strategy or the techniques that we'll have to use, that we will deal now first with the most simplest limits. How can we find this limit? Then we will go to find and complicated limits by building block into block. Let's start with the first theorem. And if you have now, as you see here, if you have limit k when k approaches, or when x approaches to a, as you see here, limit k when x approaches a, as you see in the first graph. If you look at a when a approaches to a from the right, it is k, and when you look at a when ax approaches a from the left, it is also k, because k here is a constant, it's a number. So if I told you now to find limit for when x approaches 2 is 4, it's the same as the number, and limit -2 when x approaches 3, as an example, is -2. So limit any constant when x approaches to a is the same, or is that constant. Now, if limit x when x approaches to a is equal a, like you say in f of x equal x. So f of a, you substitute a instead of x, it will be a. And f of x, if it is x plus 1, so it will be a plus 1. Here is the same limit, so here it will be the same. How? Limit x when x approaches to a, as you see here, when it approaches to a from the right, it is x, and from the left also it is x. So like I substitute a instead of x, so the answer will be a. And limit 1 over x, as you see in the graph here, when x approaches to 0 from the left, since it's bounded to the negative y axis, so it will be -infinity. And limit when it approaches to 0 from the right, it will be +infinity. Now, let's have an example. If I ask you now to find limit 3 when x approaches to -25, when x, and limit 3 when x approaches to 0, or limit 3 when x approaches to infinity. Limit k, as we said before, limit k, limit any constant. When x approaches to any value of a, it will be the same constant, as you see here. Limit 3, if x approaches to -25, it will be 3. If x approaches to 0, also it will be 3. And if x approaches to pi, it also be 3. So to any number, the limit of any constant number, when x approaches to any number, is that constant. But now, limit x, but now it's not writing constant, I will write x. Limit x when x approaches to -25, just substitute like f of x, the a instead of x, so it will be negative 25, 0, by, and so on. Look at this example here. Limit x when x approaches 0 is 0, and limit x when x approaches negative 2 is negative 2, and limit x when x approaches to by is also by. Now, the another theorem, like we said in the previous, or in the first or in the second class, in the second period, we said that if we have f of x that's added to g of x, we said that's how can we add a number? We can add the function. And how can we add the function? We can add the limits. So let a be a real number, and suppose that limit f of x when x approaches to a is L1, and limit x or g of x when x approaches to a is L2. So if this limit exists and it has a value at L1 and L2, so I can say limit g of f of x plus g of x when x approaches to a, I can now expand them. I can say that it will be limit. So let's write here now. Limit f of x plus g of x when x approaches to a, like just distribute the limit on it. So it will be limit f of x when x approaches a plus limit g of x when x approaches a. And the same if you have also minus. If the limits now of these two functions now are subtracted, you will do the same. If they are multiplied, as you see here, you will distribute the limit on it. So you will say it's limit f of x times limit g of x. And if it's divided, you will do the same. You will say it's limit f of x over limit g of x. Now, limit square root of n when it is f of x. Now, limit square root of n of f of x, like I can enter the limit inside the square root. So it will be like square root of n limit f of x when x approaches a. Now, moreover, these statements are also true. If I say x approaches to a from the left or x approaches a from the right, it will be the same. Now, this theorem can be stated informally as follows. The limit of a sum, like we see here, the limit of a sum is the sum of the limit. And the limits of a difference is the difference of the limits. And the limit of a product is a product of a limits. And the limits of a quotient is the quotient of the limit. And take care about the zeros of the denominator. And also, the limit of nth root is the nth root of the limit, as we discussed before. Now, for a special case, if you have k, as you see here, now, if you have limit f g of x, you will distribute limit of x times limit g of x, and you will say when x approaches to 1 as an example. But if you have two functions that are multiplied, we say that the limit of our product is the product of the limit. Now, Like here, there's a special case, you can say it, that if you have now limit any constant times g of x, it's a product of the constant times limit. It will be the limit, you will distribute limit it's like this. Then, as we noted before, that the limit of any constant is that constant. So as a special case here, and every time you can say I will put k outside times limit g of x when x approaches a, as you see here. So if you have limit any number multiplied by a function, just drop out or just move the constant